All right. So, well, we're moving on. Again, continuing with measurement, but a little different look at measurement is that we're going to be doing the Pythagorean Theorem, which some of you may have done and may have not have done. And it depends how much of it you did back in grade 9 or even grade 8. All right. So I'm going to start right from the top when it comes to the Pythagorean Theorem. And so the first off, it's used for right angled triangles. And what that means is the triangle has a 90-degree angle. All right, so that's important. So, and to show that a triangle has a 90-degree angle, we have a little box where the 90-degree angle is. Now, each side in a triangle is labeled for the Pythagorean theorem, A, B, and C. The key here is that one of them is important and the other ones are just the other ones. And so C is what we call the hypotenuse. It's the important side that we're going to need to identify. And by identify, I mean find this thing. And the key is that it is right across from the right angle. So across from the 90-degree angle. Now, the Pythagorean theorem, the formula for it is that we have a squared plus b squared is equal to c squared. And again, the reason that the c is important to find is because it's on one side of the equations and the other two are on the other side. All right, so again, to find c, our hypotenuse, always across from the right angle. All right, so let's try to use the old Pythagorean theorem. For example 1, I'm going to put find w. All right, so I've got my triangle here. And of course, I have to have a right angle there, so I put in a little box. We're going to find w. I'm going to say it's right there. I'm going to say this side is a length of 12, and this one has a length of 7. All right, so again, the important side is to figure out which one is the hypotenuse, or the one that's going to be the c in our equation. All right, so again, when I'm looking at my triangle here, I see my 90-degree angle, and I go across. So w is actually my c. Now, as I said, the other sides are just the other sides, so it doesn't matter. I'll call this one A and the 12 B, but it really doesn't matter which is which. The C is the one that matters. All right, so now if I'm using my Pythagorean theorem right here of a squared plus b squared equals c squared. All right, so my A, and this is, you're going to find out here in the next couple weeks, I always love to label my diagrams. All right, so A is 7, so I don't get mixed up. So instead of a squared, I'm going to write 7 squared. And instead of b squared, well, b is 12, I'm going to write a 12 squared. All right, and then C, again, which is our unique side, our hypotenuse, it's across from right angle. Well, C is actually called W. All right, so instead of C squared, I'm going to write W squared. All right, so now I got everything in the right order. Now, I'm going to calculate my left-hand side of my equation. All right, and again, following Bedmus. This is one of the reasons we did Bedmus in day 1. So I have to do the exponents first. And again, 7 squared means I take 7 and I multiply it by itself twice. So 7 times 7. And in my calculator, I got 7 times 7 is 49. Now I also have to do the other exponent, which is 12 squared. And that means 12 times 12, all right, which is 144. And that is, again, equal to W squared. Now, I'm still not done yet because I can put these numbers together. And anytime I can do a calculation, I like to do it. Simplifies things. All right, so I'm going to add 49 and 144, and I get 193 is equal to W squared. All right, now, again, we're solving for W. I want to get W by itself. Does anybody know how I'm going to get rid of that little 2? How am I going to get rid of that little 2? Any suggestions? Because remember in our last examples, we had to get rid of numbers by x. This one's w. There was only one way to get rid of that little 2. And that is if I take the square root. Now again, no, I can't divide. If I divide, that's when I would have a 2w. I would divide by 2. If I had 2 plus w, I would move the 2 over to the other side. But this is a unique situation where I have a little 2 there. Just it's an exponent. So I have to take the square root. All right. And what I do to one side, I got to do to the other. All right. Now, when I take the square root of 193, well, I better grab my calculator here. And when I take the square root of 193, I get, and again, always to 2 decimal places, 13.89. And there we go. And so that would be the length of our side W. All right, now I'm going to try another one here. Example 2. All right, so I got another triangle, of course. And it's got to be a right angle triangle, so we'll put a box there in the corner. I'm going to say this side here is 21. We have a 6 here, and let's go with an x here. Okay. Now, again, when we're using the Pythagorean Theorem, the key thing is you've got to identify which side is C. And as I said before, it's always across from the right angle. Right? Across from the right angle. So in this case, I go across from the right angle, and there we go. All right, so that is telling me that 21 is my C. Again, I like to label my diagrams because then when I put my information into my equations, I don't get mixed up. And again, the other ones are the other ones, so it doesn't matter. I'll say A is 6 and B is X. All right. So again, I'm going to use the Pythagorean Theorem here, which is, again, A squared plus B squared is equal to C squared. All right, so now substituting into my equation and just replacing things. A squared. Well, A is 6. So instead of an A squared, I'm going to have a 6 squared. All right, B is X. So instead of a B squared, I'm going to put X squared. All right, then again, our unique side, which is our hypotenuse, is C. C is 21. So instead of a C squared over here, I'm going to put a 21 squared. All right. Now, again, anytime I can figure some stuff out, I'm going to do it because it makes things easier. I've got 2 exponents here that I can figure out. All right, so I'm going to make them normal numbers and not exponents. And so 6 squared, again, would be 6 times 6. Which is 36 plus x squared. Can't do anything with that x squared. 21 squared, that's a bit of a bigger number. Let's see here, 21 squared, I get 441. All right, now, I can, this is a little bit different situation than I had over here. I want to get x by itself. Well, I have this 36 on this side, and it's not attached. So what I can do is move it over to the other side of the equal sign. All right, so now all I have, because I'm moving that 36 over, is an x squared. That's all that's over there. All right, now on the other side, I have that 441. But now I'm moving that 36 over. And when something moves sides, it changes signs. Changes sides, changes sign. So that 36 comes over, it's going to be a minus 36. All right? Because it's, again, when it changes, goes over the equal sign, anything, if it changes sides, it changes sign. I can figure this out. That's a number. Again, I like to shrink things down. All right? So I got my x squared. I take my 441, I subtract 36, And I end up with 405. All right, but still not done because, again, we want to get x by itself. Got to get rid of that little 2. And just as we did at the bottom here, to get rid of that little 2, I got to take the square root of it. What I do to one side, I got to do to the other. So we're going to take the square root of both sides. All right, so that gets rid of the little 2. And now what I'm looking at is I take the square root of 405. All right, and let's see here. That's going to be my final answer. And I get 20. Again, going to 2 decimal places here. 20.12. There we go. All right, so a little bit different scenario here because in this case, we found the hypotenuse, and on this side, we found a different side, one of the other sides. All right, so now I'm going to try a few other questions here. All right, so example 3. I love this example because it ties in with my beloved Blue Jays who are on a roll right now. So example 3 says this. The bases on a baseball diamond are 27 meters apart, which is true, 90 feet. All right, how far does a baseball travel if it's thrown from home plate to second base? All right, so I'm going to draw a little diagram here. It's a little bit of a word problem. All right, so I got a baseball diamond. Now, excuse me if my art's not very good. I'm not much of an artist, a bit of a math teacher. All right, so I draw a baseball diamond. Trying. Oh. There we go. So there's my baseball diamond. That's pretty good for me. All right, there's the base. There's the base, and we got home plate here. So there's home plate. All right, first base, second base, third, and home plate. All right. Now, again, in this question, it says that each base is 27 meters apart. 27 meters, 27 meters, 27 meters, and 27 meters. All right, now what we're looking for is when you throw, how far is it from home plate all the way to second base? So that's the distance we're looking for here. All right, now, again, when we're looking at a baseball diamond, it's not a triangle. But when I look at this purple line and then my red line here, I actually do form a triangle. And there, that base is actually my 90-degree angle. All right, so there's my box. So if I'm trying to use the Pythagorean Theorem to find my distance here, again, it's key to figure out what C is. Well, it's always across from the right angle. Right? This right angle's cut into pieces, so it's not a 90-degree angle. This one also is cut into pieces because of the purple line. So it's not a right angle, but here we do have our base. So our distance is actually our C. Again, the other sides are just the other sides. So I'll say this side's A and this side's B. All right, so here we go. Again, we're going to use the Pythagorean Theorem. So we have our A squared plus B squared is equal to C squared. All right, so plugging in my information. A is, look at this. A is 27, B is 27. Can't really mess this substitution up, can I? So if A is 27, so instead of A squared, I'm going to have a 27 squared. B is also 27 because, well, your bases got to be equal distance apart, so we're going to have a 27 squared. And C, well, we're calling it D because it's distance, so D is, instead of C squared, I'm just going to write a D squared. All right, so now, just like I've been doing, I want to simplify this. All right, so again, I can do my exponents first here. So I need 27 squared, and well, I got 27 squared. So I'll get my calculator out here. And 27 squared, again, that's 27 times 27 if you don't have a fancy calculator there, scientific calculator. I get 729. Well, 27 squared is 729 is equal to d squared. All right, well, again, I can simplify that because those two numbers, 729 plus 729, I put those together and I get 1458 is equal to d squared. And again, we want d because that's our distance, right? So again, I got to get rid of the little 2. Last step, it seems like, in all of this Pythagorean theorem is take the square root of both sides. All right, and so the distance is the square root of 1458. And I figure that out to be 38.18 meters is the distance from home plate to second base. It's the reason that you will see people steal second base, but trouble stealing third. That's why you don't see too many people steal third, because the catcher only has to throw 27 meters to third, and but it has to throw 38.18 meters to second. Little useless knowledge for you. About 100 years ago, before they changed the rules and guys were using gloves that were terrible in the major leagues, people actually used to steal first base. They go from second to first so that people would throw and maybe miss, and then you could create some runs. That actually happened back in the early 1900s, but they switched the rule. So you can't steal first base anymore. All right, last example. Example 4, where we're talking about TVs. Now, it says, if the length, oh no, the TV isn't your homework. If the length of a rectangle is 14 meters, and the diagonal has a length of 21 meters, what is its width? Okay, so let's read that again. We got a rectangle, so I'm going to draw that first. So there's my rectangle. And of course, if you're going to have a rectangle, it's got to have square corners, 90-degree corners, so I'll put those little boxes in there. Now it says the length of this rectangle is 14 meters. Go. And the diagonal has a length of 21 meters. So what does that mean? A diagonal is when you go from one corner. Let's draw a little different color here. When you go from one corner to the opposite corner, not the one beside it. So that purple line is your diagonal, all right, which it's saying here is 21 meters. And what we're looking for here is the width. So I'll put, I guess, another W there. We're looking for the width of this rectangle. All right, so again, we're going to use the Pythagorean theorem here. A squared plus B squared equals C squared. All right, so again, we've got to identify which one's A, which one's B. Well, actually, which one's C. That's all that matters, right? Because the other ones are just the other ones. And again, there's our triangle. You can kind of draw it there, outline it in red. And again, our C value, the hypotenuse, is across from the right angle. All right, so there's our C, which is 21. The other ones are the other ones, so I'll say 14 is A, and this W here is going to be B. All right, so now it's just time to substitute in the formula, just like we did before. All right, so instead of an A squared, A is 14, so I'm going to have a 14 squared. B, what do we call a B here? B is W, so instead of a B squared, I now have a W squared. And our C, which again is called our hypotenuse, is 21, so instead of a C squared, I'm going to have 21 squared. All right, so again, I like when I can figure things out, I'm going to calculate them. So I got a 14 squared. That's 14 times 14. My calculator, let's see, we get 14 times 14 is 196 plus W squared. All right, and then 21 squared. I had that earlier today. 21 squared, 21 times 21 is 441. All right, now, again, the goal here is to get W by itself. Now, the first thing I'm going to do to get W by itself is I have this 196 here. It's not attached, so I can just move it. I move it over. All right, and so all that's left now on this side of the equation is a W squared. All right, I have this 441. I bring the 196 over, so now it's changing sides, changes sign, so now it's a minus 196. All right, I can put these two numbers together now. They're on the same side. All right, so I take my 441 and I subtract 196 and I get 245. Still not done yet. We got the one last step. Again, always with the Pythagorean theorem, your last step is going to be taking the square root of both sides to get rid of that little 2. And so the width of this rectangle is the square root of 245, which I'm finding to be, again, going to 2 decimal places here, 15.65, and our units here were meters. There we go. So again, I know that some of you have done the Pythagorean theorem, some of you haven't, or some have done the Pythagorean theorem, but you never had to find a side that wasn't the hypotenuse, which again is a little bit harder because we have to move a number over to the other side of the equal sign, where then when you're just finding the hypotenuse, you don't have to do that. But again, there's a little recap of the Pythagorean theorem, which we are going to need. It's one of those theorems that, or one of those equations, it never goes away in math. And no matter what level of math, what grade you are in math, the Pythagorean theorem is always used. So again, we're going to be using it for our next unit as well. And so there we go, part of measurement. Now, just going to hit that stop.